Okay, on the 5.1 worksheet 2, problem number 6, I just got done making the video for problem number 5. If you haven't watched this one yet, you might want to, guys, because these two problems have the same boring thing, in my opinion. They're both strictly decreasing functions. Y equals 2 over x is a hyperbola that's going to be located in the first and the third quadrants. I didn't draw that terribly well. First and the third quadrants right here. We only need the part that's in the first quadrant right now, so forget about the rest of it. And we have an interval here that is starting at 1 and ending over here at 5 somewhere. And they wanted us to find I4, which means approximate the area under the curve using inscribed rectangles, and they're telling us to do 4 of them. So how are we going to do that? We need to partition our interval into subintervals. So you guys have been through this before right here. They gave you n, they gave you a and b, so the formula we need to know here is that delta x is b minus a over n. So for us in this problem, it's 5 minus 1 all over 4, and this is really convenient. 4 over 4 is 1. That's the width of our subintervals. So I'm going to bisect the interval from 1 to 5. That gets me to 3, and then bisect each of those intervals, and that is how we're going to partition this subinterval. Okay, so from there now, just trying to get my colors to match, we need to make rectangles on each one of those 4 subintervals, but the important part in this problem is because we're doing inscribed rectangles, these rectangles must stay below the curve. Now, don't write this down. If I tried to do a left endpoint rectangle here from 2 to 3, that's no good because I'm sticking above the curve and I don't want that. So because this function is strictly decreasing from left to right, everything here needs to be a right endpoint rectangle. This that I'm drawing right here, that's what rectangle number 1 would have to look like. And the second rectangle would look like that. Here's your third rectangle right next to that. And the fourth rectangle, going to be kind of hard to see, but it's going to look something like that. In this case, guys, because the curve is strictly increasing, don't write this down always here, but in this case, I4 is simply equal to R4. That would not be the case if this function were increasing or if it changed behavior from increasing to decreasing. So here we go, guys. I4 is equal to, all right, now because we're dealing with regular subintervals, they all have the same width right here, your delta x, which in this case is 1, can get pulled all the way out in front, which doesn't really accomplish anything in this problem, but in others it will. And then we're simply adding the heights of the rectangles. So the first rectangle now, its height is going to be f of, and we want the right endpoint of this subinterval here, which is right there at 2. So f of 2 is the height of the first rectangle. The second rectangle's height is going to be f of, the right endpoint of subinterval number 2 is right here at 3. There's f of 3. And now I think I get the pattern, guys. The third subinterval has a right endpoint of 4, and the fourth and final rectangle right here, subinterval, has a right endpoint of 5. And since I'm using f, I should have called the function f of x, and here we go. Now again, there's no point in putting that 1 there, but I want you guys to get in the habit of remembering that. It's an easy thing to leave out. F of 2, we'll plug a 2 into this function here, and 2 over 2 is 1. F of 3, that gives us 2/3. F of 4, that's going to be a 1/2. And F of 5 is going to get us 2/5. Now, I would allow you guys to use a calculator here if we needed to, but for our purposes here, let's take a look. 3 and 2 and 5. So it looks like our common denominator right here is going to be 30. All right, so we end up with a 30 over 30 from the 1, a 20 over 30 from the 2/3, a 15 over 30 from the 1/2, and a 12 over 30 from the 2/5. So what's that going to do for us, guys? That is 50, 65, and looks like 77 over 30 is going to be our answer here for that inscribed rectangular approximation on problem number 6.